In this section, 5.6, we're going to learn how to solve exponential equations as well as logarithmic equations. So I took this example that I want to look at from the PowerPoint presentation. So let me share my screen so we can take a look at the problem. And we are we're modeling the world population. And the model that we're given here is P of X. P stands for the population. X is the year. And that the population is modeled by 7 times 1.01 raised to the power of X minus 2011, where X is the year. And in this particular problem, we are asked to solve the equation when the population reaches 8 billion, but I wanted to that's by this model, that would be the year 2024. So I want to use a more up-to-date. You can see the copyright on this was 2018. So I want to use a little bit more up-to-date value. Let's see what the population is going to be in when it reaches, I'm sorry, what year it's going to reach 9 billion. So I'm going to do that. I've got, what year will the population reach 9 billion? And here's our model. So I'm going to go ahead and the population is 9 billion and P is in billions. So I'm going to substitute P of X with 9. And we already know that's in billions. And then we have 7 times 1.01 to the power of X minus 2011. This is an exponential equation. Why? Because the variable that we want to solve for is in the exponent, and that's what makes it an exponential equation. And the trick to solving an exponential equation is to take the log of both sides. And the reason we do that is because the logs allow you to bring the exponents out of the, take the whatever's in the exponent out front. Remember that property? So that's what we're going to do here. But before we do that, we're going to isolate the piece of the equation that has the exponent. So that would be this piece right here. So I'm going to go ahead and divide both sides by 7. And I would like to have my X on the left-hand side, so I'm going to switch sides. So we have 1.01 to the power of X minus 2011. And that is equal to 9/7. And this is the point at which I'm going to take the natural log of both sides. Or I could take the common log, it really doesn't matter. I like to use the natural log because it's only right, I only have to write 2 letters instead of 3. So I'm going to take the natural log of both sides. And by the property of logarithms, this allows me to bring my exponent out front. Remember that property? So this is going to become X minus 2011, okay? And then I'm multiplying that by the natural log of 1.01, and that's equal to the natural log of 9/7. And my marker's running out, so let me see if I can find a better one. I hope this one works better. Okay, so now I still want to isolate the X. So I'm going to divide both sides by this. All right. And this goes away. And I still have this minus 2011. So I'm going to add 2011 to both sides. And I'm kind of running out of room here, so I'm going to move up here. So now I've got, this goes away. So I've got X by itself on the left-hand side. And then all I have to do is calculate this in my calculator. So let me share my screen. And I'm going to take the natural log of 9 divided by 7. I'm going to close my parentheses, and then I'm going to divide that by the natural log of 1.01. Close my parentheses, and then I'm going to subtract 2011. Now, by the order of operations, this is going to Oh, plus 2011. I was wondering, what in the world? I didn't, you're not supposed to subtract 2011, you're supposed to add 2011. Sorry about that. Okay, so here we go. We are in the year 2036 is when the population by this model should reach 9 billion. So what the takeaway from this is, you just want to remember to take the log of both sides, either use the natural log or the common log, because that's what's in your calculator. It's not going to benefit you to use some other log. So just take the log of both sides, bring that exponent out front, and then just solve the equation as you would any other equation.